We are doing 2014 A-Maths paper 2, question 8. In this question, we are told that a particle traveling in the straight line passes through a fixed point O with a speed of 8 meter per second. At the point O, the velocity is 8 meter per second. The acceleration of the particle t second after passing through O, that means this is t second after passing through O, and that is to say at the point O, t will be equal to 0. So t second after passing through O, the acceleration is given by minus e to the power of minus 0.1 t. The next information we are given is the particle come to rest at the point P. So let's say this is the point P and this particle is at rest here. And we know that when a particle is at rest, v will be equal to the value of 0. When the particle is at rest, the velocity will be equal to 0. This is a fact. In part 1 of the question, we are asked to show that the particle reaches P when t equal to 10 ln 5 seconds. So at this point, t must be 10 ln 5. Okay, we are going to do this question based on this fact, v equal to 0. If we can get the v expression, we just equate the v expression to 0. We should be able to get the value of t equal to 10 ln 5. Okay, so we need to find the expression for v first. And we are given the acceleration expression. Acceleration is given by minus e minus 0.1 t. To find v is the integration of the acceleration. Will be integrate this expression here respect to t. This will give us v equal to minus e minus 0.1 t divided by minus 0.1. The number in front of the power t. Then plus a c. This will give us v equal to 10e minus 0.1 t. Now we need to find out the value of c. And we are told that at the fixed point, v equal to 8 meter per second. So at this fixed point, we know that t equal to 0. That means when t equal to 0, v equal to 8 meter per second. So from this, we are going to substitute these two values into this expression to find c. Be careful, e to the power of 0 is a 1. Okay, so c will be equal to negative 2. Therefore, v will be equal to 10e minus 0.1 t. We substitute the c by minus 2. So this is the expression for velocity. We are supposed to show that at this point P, the t is 10 ln 5. And we know that at this point P, v is equal to 0. So we set v to 0 and find t. v equal to 0, so 0 equal to 10e negative 0.1 t minus 2. So 10e negative 0.1 t equal to 2. Try to make e the subject of formula. Then we ln both sides. This power, based on the law of logarithm, can be bring down. Ln e is 1. So t will be equal to, bring the negative 0.1 over. So it will be a negative 10. Now we are supposed to prove that t is this expression here. What is the main difference is we have a ln 1/5 and they have a ln 5. So what I can do is I can rewrite this as ln 5 to the power of negative 1, because 5 to the power of negative 1 is actually 1/5. Then I bring down the negative power. Negative will be a positive, which is exactly the expression we're supposed to prove. Shown. In the second part of the question, we are asked to calculate the distance OP. That means the distance from here all the way to here. To do that, we have to get the displacement expression. And the displacement expression is the integration of the velocity. The velocity expression from tan part 1, we know that is the expression tan e negative 0.1 t minus 2. Okay, we have to integrate this respect to t, and this will give us tan e negative 0.1 t divided by negative 0.1. Integrate a constant 2 will give you a 2t. Don't forget about the plus c. So let's simplify this expression. Now again, we have to find the value of c. So we make use of this information here. When t is 0, the displacement from O is also 0. Okay, so from here we substitute t is 0, s is 0 to find the value of c. So s is 0 minus 100, e minus 0.1, t take the value of 0, minus 2, t take the value of 0 again. So from here, be careful, e to the power of 0 will give you a 1. So this is minus 100 times 1, so bring over be 100. So this is 0. So c is 100. Therefore, the displacement expression is this. C is substitute by 100. Now, this displacement expression tell you the distance from O. To calculate the distance OP, we have to substitute t equal to 10 ln 5. Therefore, when t equal to 10 ln 5, s will be equal to minus 100, e minus 0.1, t substitute by 10 ln 5, minus away 10 ln 5 plus 100. Okay, so from the calculator, this will give us the value of 47.81 or 47.8 meter to 3 SF. In part 3, we are asked to show that the particle is again at the point O during the 50th second. 50th second means t start from 49 to t equal to 50. Okay, so basically what it means is from t equal to 49 to t equal to 50, at this instant, the particle should pass through the point O. In part 2, we have obtained the displacement expression. Let's run through the thinking process before we solve the problem. The first method of solving the problem will be we can set s to be 0, because when the particle pass through the point O, the displacement will be 0. And from here we can solve for t. If the t value we can obtain anywhere from 49 to 50, then we have proved this statement. If we set s to be 0, then we will get this expression. But we are problem solving this equation because the variable t is at the power of the exponential and the variable t appear here. And because we don't know how to solve this equation, we cannot use this method to solve this problem. Another possible method will be we can find the displacement from O when t equal to 49 and the displacement from O when t equal to 50. With this time frame with the distance from O, we can tell whether the particle did in fact pass through the point O or not. Let's try to solve this problem using this method. When t is 49, the displacement from O is 1.26 meter. That means this distance here from O is 1.26 meter. When t equal to 50, the distance from O is minus 0.67 meter. Since we know that a positive distance is measured in this direction, a negative distance means it will be measured in this direction. That means minus 0.67 meter is the distance here. In conclusion, at t equal to 49 seconds, the particle is at this point here. At t equal to 50 seconds, the particle is at this point here. That means from t equal to 49 to 50 seconds, the particle is traveling in this direction. And from this fact, we know that the particle did pass through the point O. With this, we state our conclusion.